Okay, so my name is Tom White, and we're here to talk about the Siemens curriculum for manufacturing and automation. In general parlance of things, it's the kind of culmination of a mechatronics approach to STEM. Siemens is a small company. They have about 380,000 employees. And we got together with them a few years back to discuss, what might be needed to improve the workforce for the 21st century. Um, Obviously, we can't train people for the education that I have. That's, kind of antiquated. My father used to kid me and say that, his entire studies up until the time he was like 22 or 23 saw him his entire life because the knowledge level didn't double every 18 months like it does now. So at any rate, the things that we used to do are long gone, and we don't know what the students of tomorrow are going to be facing. So when we sat down to write this, we came up with the best approximation of what we thought might be needed in the future. And so I just want to take a brief moment, introduce myself, and tell you who Matt is, and then I'll let Dick introduce himself. So let me just start by saying, I'm Tom White. I've got maybe 40 some odd years of educational experience. I've lost count in there someplace. And a few years back, I met a gentleman named Matt Bruce, who works for Siemens, and his job is to support solid edge software in the academic program in the Americas. And we got to talking. We decided that we could do more, and we came up with this way in order to do it. So hopefully Dick can chime in here. Dick, are you there?
Okay, Tom, can you hear me okay?
Yeah, we can hear you.
Okay, good. My name is Dick Blaze, and Tom and I live probably 15 miles apart. I'm on the east side of the Hudson River in upstate New York, and he's over on the west side in Saratoga County. But we work together at a school district called the Shenendehowa Central School District, where the Project Lead the Way curriculum was invented. And after running it in that district for about 10 years, we were connected with a charitable foundation that provided a substantial amount of money to enable Tom and I to create Project Lead the Way and to hire some incredible people who are no longer there, by the way, but and over a 10-year period, we were able to develop the curriculum with a lot of partners and implement that in over 3,500 school sites in every state in the country. So now we have taken what we've learned about curriculum development. We parlayed that into a period of work time with the Southern Regional Education Board in Atlanta. And now we are developing this curriculum for Siemens, and we feel pretty proud of how it works and how it's been developed. We think it's, we think it's the best thing out there right now. So with that, I'm going to turn it back over to Tom. And Tom, you're on.
Well, actually, I'll keep you there, and I'll let you talk about the rigor and relevance of the projects that we've developed.
Okay. Tom and I are very strong believers in contextual learning. Another way to describe that is something called project problem-based learning. And so that's the modality that is used in all of these projects. It's contextual in nature. It integrates not only the technical standards that we create for the projects, but it also integrates the academic standards in English language arts, mathematics, and science. So when teachers, like science teachers, look at this curriculum, they get very excited because they see in a contextual way how their next generation science standards come to life. And that's the beauty of integrated curriculum. Um, we feel that that whole issue of having a curriculum that's rigorous and also relevant is the power that allows this to become a very successful way of engaging students. And to piggyback a little bit upon what Tom said in his introduction, a related quote to that is, "The future of education is not what it used to be." And so when you hear Tom talk about this curriculum, that's what you need to think about, is this is the kind of educational experience that will launch career pathways for your young people that are in school with you every day. So, Tom, I am done. Thank you.
Thanks, Dick. So, just taking a quick look, this kind of gives you a snapshot of the way the curriculum is designed. We want to see groups of young people working together, solving problems. And so each unit or project-based or problem-based problem we throw at the kids forces them into these collaborative pieces. And between the way we have set it up and a few other pieces, they come away with a whole lot of experience in running teams, in forming teams, and using a problem-solving process. So when we were doing this, I did a little research, and I found that there's a National Association of Colleges and Employers. And what they do is periodically do surveys, and they go off and they query all the colleges and employers, and they say, well, what skills are you folks looking for? What are the top 10? They actually asked for a whole lot more than 10, but I took the top 10 because I thought they were pretty indicative of what we are trying to do. And so they're looking for, if you read across the bottom, leadership, abilities to work in teams, communication skills, both verbal and written, things like strong work ethics, analytical and problem-solving skills, flexibility, and finally down at number 10, technical skills. So when you think about all those skills are not something that you can create a lesson and teach. Those are all skills that come from experience. So the more times we put them in roles of leadership or places like that, the better off they're going to be in 5 years when they can talk about, well, how do you approach these things? And so in an interview, they're going to be able to, explain all the stuff that they've done and how that's going to really help those companies. So there's no cost to the schools for the curriculum or the software. And they're obviously, you're going to end up with materials and some schools already, I talked to one school in Minnesota yesterday who had basically everything they've needed. They've accumulated over the several years. They were just looking for something to really promote, students and what they were doing. So this young gentleman I met a few months back, I stopped by his school, and they have this class being taught in a modular classroom. And it's off in the middle of nowhere, and it's really kind of tough for everything, but the kids love it and they're actively engaged. I get a few pictures from the teacher on occasion to show me what they're up to these days. So the project he was working on here was creating a automated clamping system. His father runs a post and beam business, so they wanted to be able to, put joints together quickly. And so he was experimenting with pneumatic, clamping devices, and he's got a Siemens PLC there that, he wrote a program for it, and, I think I have a picture of that later. So everything is a project. The kids all have a engineering notebook, and these engineering notebooks allow them to keep track of the flow through a project. So they do all their sketches, they do all their note taking. I don't know about you, but when I find a great website, I have to write it down, because the next week I'll spend 2 or 3 hours looking for that perfect website and I'll never be able to do it. So I got into the habit a long time ago of documenting everything. And this is something I think that student teams really benefit from. I know my kids used to have a note pile in their backpack, and that never worked out well for them. So, having everything in one space written down really helps them. So in this one, we integrate all the standards, and then we turn the students loose so they can practice, and come up with a solution. So there's no right solution to any of these projects. So, it's a little frustrating for students and teachers to begin with, because everybody's looking for that perfect line to, if I put my answer on this line, then you'll give me 100. And that's really not how this works at all. In the future, everybody is going to come to work and the boss is going to say, you need to do this. And, that'll be the end of the discussion. So we need to, turn them in. So in this one, they were designing some script to go on and be engraved into a nameplate. So they were, learning how that works. They had to write their own code for this. And so they would start with initials, and then they would go through and I don't know if you can see it over on the left-hand side. He's got his initials done up on a piece of graph paper, and he had to come up with all the points. And then he went through with, well, how do you get from point to point? And then he wrote the code by hand from there, entered it in, and used that to control the milling machine. So this gentleman was doing circular interpolations and a few other pretty nifty things. So your math teachers will take credit for the students understanding polar coordinates a lot better than they used to. So that's always a good thing. So if you look, here's that automated clamping device that I was telling you about. So they, came through and they did it, a mock-up of it, and then they actually built the thing. And, they powered it all, and it really saved them a lot of time and effort. And so when you talk about the next generation of manufacturing, it's all about how can we get a product to market much faster. So, and I'll show you a little bit about the curriculum in a second. And if you'll notice, these students are all presenting, all right, because we think presenting is a wonderful thing. And so what they did at this school is they set up a series of tables, and they invited the community to come in and go from table to table, and they had to explain to people about what they were doing. It's really neat if you can find what we call an authentic audience, where you have several people that actually do this for a living, to give them feedback. And then we also encourage them to present just to average folks, because it's important to be able to speak to just about anybody about what you're doing. So this young lady had just done a what we call a reverse engineering project, where she totally disassembled the product and measured it all out, drew it all up, and then she's created new parts to go with it, and she's using a 3D printer to print those out. So this is another project that she had done. This is a clothespin, and she reverse engineered a clothespin. And if you'll notice, all the documentation that she created in her engineering notebook. And down at the bottom is the actual clothespin that she printed out. The spring was the toughest part. So I talked a bit before about this engineering design process that we want the kids to go through. And each time they do it, they get a little better. But basically, it always begins with something, so we can learn about what the problem really is. And one of the first pieces of writing is to write a problem statement. So we can begin that communication back and forth between students as problem solvers and their clients. And it allows them to, make sure that things work the way they want it to. So the best way to show you what this curriculum is about is to show you, obviously, and we're going to take a little closer look. This is a young lady from Alabama. She was working on a prosthetic foot for a soldier who had come back, and she made Good Morning America. They had the soldier on with the foot fitted to him, and this is the process that she went through. And as you might imagine, she doesn't have to worry about what she's going to do for her future. Right now, she's looking at biomedical engineering so she can further develop some of these ideas that she was thinking about. So give me 2 seconds to call up the curriculum. Okay, so this is the manufacturing and automation curriculum. And I might zoom in on a couple of places, but basically these are just a resource for teachers, but it fits several pieces of information that everybody needs. So from district curriculum people to state curriculum people to teachers and students and parents, it's all in here. And once you learn how to navigate it, it's not too bad. So we'll come down, because what I want to basically begin with is just to show you that there's 4 major quarters in this. Although I worked with schools that do it in a half a year at like a career center, and I've worked with a couple of schools that wanted to dig a little deeper, use it with existing courses, and so they're doing this one over 3 years. It allows them to see a bunch of things. So the first quarter is all about, design for production. All right. So how do you design something so it can be made quickly? Manufacturing is important, and also assembly. So when you think about, a windmill, and we have a lot of windmill farms around the country, putting those things together is a nightmare. One of my seatmates in an airplane ride one time was a gentleman who goes up, 300 feet off the ground and puts these things together. It's really, really fascinating to talk to. There's a nice reverse engineering project. And if you look at it, this is a set of bolt cutters, and the little one next to it is the one that the kids measured up, and, everybody took different parts, and they had to talk about tolerances and how do we make sure that if I make a part, your part fits it. The second quarter is about CNC equipment. So what things can we design? How do we get around to learning how this computer can control the whole manufacturing process? How do we keep tabs on it all? How do we evaluate it? Because you can't just make parts, you got to make sure that they actually will function in the future. So there's a number of different pieces that we need to understand about the manufacturing process to do that. And to Dick's point when he was talking about they need to see things that they can understand, I remember my first go around, we were drawing bearing plates and gussets and things like that, and I had no idea what they were. So a lot of these were selected so students would have some idea of what they were. They could do a little bit of extra research and then perhaps utilize it to come up with some new things. So, and if you'll notice, you'll see select one of the next 2 projects. So there's a lot of places where there's a lot of choice for teachers and students. Generally, when we give choices, they take about the same amount of time, or they should take about the same amount of time. So it's a really good way to make sure that everybody stays interested, because if you're interested in what you're working on, you're going to work a lot harder. And it also keeps our teachers from getting stale. You know, if you do the same thing year after year after year, you know, eventually it's okay. Throw the handout on the Xerox machine and away we go. We don't want that. The third quarter is all about automation. So we're working with learning how PLCs operate and controlling models with PLCs. And so in that way, they're learning, you know, ladder logic and a few other, you know, languages that all go together. So they can come away with a certification using a PLC. And again, you know, select one of the following two projects. Okay, so you're either going to do an elevator or parking lot, you know, type gate. By the time we get to fourth quarter, we're really into mechatronics big time. So there's an automated pneumatic clamping system. There's a feeder system. There are conveyor belts for sorting, and then work cells. And so when you think about all these different pieces that they learn through these projects through the year, now they can put them all together and end up with a chunk that actually works for them. So I'll just pick one at random because it always is good to, you know, start at random. So every project is linked from that point, and then it takes us up, and every project is built the same way. So, you know, when we give kids a problem, we want them to use that design process to kind of go through and follow along with everything that, you know, they need to do to create their solutions. So the first thing we show them is an introduction. And so they get a feel for it. There's a purpose of the project, so they know why they're doing it. So anybody from the outside of the classroom comes in, they can take a look at this and say, oh, well, that's why they're doing it. Some concepts that, you know, we want everybody to walk away with at the end. And if we point out the major things in the beginning, then people can use those as research guides to launch from. There's some real world application videos. So if you were to click on one of these links, that would take you to some place that, well, take you to Siemens. So you can take a look at, see how they're using these things in factories around the world. So it has real life applications to it. There's an outline that we developed for the whole entire course. And these are the sections of the outline that, you know, this, you know, problem touches on. We've got standards. The career and technical standards are ones that Dick and I sat down and wrote for this because we're interested in learning. You know, we wanted to make sure that, you know, our standards were more than introduce and you know, make students aware. You know, so if you look at these standards, they're all about, you know, communication and evaluation and applying and you know, really high level language. Then we get into the math standards, and you know, so in this one they're creating equations. They have to do force from pneumatic cylinders, so they know how much pressure they're going to be applying, so they can control air pressure, et cetera, so they don't crush pieces. Equations that describe numbers and relationships. They're talking about quantities, inferences, and justifying conclusions. So when you talk to the math department, it's about the things that these you know, STEM-related problems are going to introduce. This is the part that they will understand innately because this is what they're after. Then we have some standards for speaking and listening and writing and presenting, you know, so those are all in there. Standards for technological literacy, because those become important to state directors so they can, you know, say that it meets their standards for Perkins funding. We talk a bit about assessment, or how do you assess what the students have actually done, you know, so we're not really looking at the final product, we're looking at the process that they use to make it that far. And so, and now we get into the day-to-day. All right, so here's what students are really going to do. So, like all good project-based education, we begin with an essential question. So, in this one, it's like, how do we design a system to automatically deliver a part using pneumatic and other components? So we didn't want to limit them to what they could use, although we thought that they would come across this fairly readily. Then there's a scenario, and we always give the students a package to take a look at this. And it serves several purposes. One of the purposes is to show them that, okay, people who do this for a living, these are the types of things that they work on. And if you're interested, then you can do a little career research and find out what kind of training you're going to need to do this. Do you need to go to a community college and get a certificate, a 2-year degree? Is it a 4-year degree? Where are these jobs? Are they in my neighborhood, or do I have to move? So, my son did a field of study, and there are 2 places in the country where he can work. So right now he's working in Boston, and if he decides to change jobs, maybe he'll have to move to California. So, these are all questions that you have to answer for yourself as you move forward. So we want to make sure that they understand that. There's some design requirements. We tell them these are the things that we want to see. And if you look at it, all right, so a prototype has to feed in the correct position. It's got to wait for a signal before you can go to the next part, et cetera, et cetera. So it lays it out fairly well, but it doesn't solve it for them. Then we talk about the research that they're going to do. What are their deliverables? And if you notice, the engineering notebook is the very first thing. And we talk about, sketches and prototypes and things. And then we get into the daily plan. And, Dick and I have been designing these things for probably 35 years. And we know that, if you have 2 classrooms, they'll both be at different places in the project, depending on the day and which way the wind is blowing. And if you have 100 schools, well, then you've got 100 different places where people are, and et cetera. It grows exponentially. But the first day is always reviewing this design process with students, so they have a place to begin. And so if you take a look at it, each one of these things, they're hyperlinked. And so I'm on 331. So if I talk about design process, it goes to the design process, and it talks about the whole, piece that we want to see them do. And it kind of gives them a step-by-step walking guide to solving the problem. We talk about vocabulary terms, because one of the ways that the teams begin to figure out what the problem is about is they split up the vocabulary terms between them all. And then they have to come up with definitions that they can all agree on. And so it's a team effort. And then, pardon me, then they all, start going through and saying, well, what are the things that we have to research and understand? And then there are some tutorials. For example, there's one on pneumatics and control. There's some other things like logic and decision making on 333. So we go to take a look at logic and decision making, and we talk about setting up the PLC, and it shows in the schematics. So the students are learning not only the language, but also how to wire a PLC to give it, the solutions that they want. So it's not a cookie cutter approach where there's a notebook where they go through and it says turn switch A and wire switch B, that type of thing. They have to figure out how to do all this. But we give them enough to give them an idea, and they figure out how much they really want to do for the whole thing. And so as they go through, they get to the other end of the project. There's that vocabulary list. And then there's a whole pile of resources for them to use because, they can't just, leap into a project and hope you get to the right site. So we kind of check these all out so they're working for students. So if you want to know how to write an engineering report or know what an engineering notebook is, there's some stuff there. There's some pieces on ladder logic, some basic logic, even some examples of part feeders that they could click on to say, oh, what do other people do? Because that's, in engineering, you always check what other people do. It's much cheaper to go to the hardware store and buy a bolt than it is to get your lathe out and actually turn one. I've done it both ways, and really, trust me, it's a lot easier to go to the hardware store and buy one. There's a chunk on PLCs. This one has some pneumatic clamping and some state diagrams and flowcharts for, how do you design a program to do what you want it to do. And then eventually you get to the end of the project and then at the end you start the next one. All right, so you're going to build a conveyor sorting system next. So at any rate, so that's a look at the curriculum. I encourage you to download this because it's a whole lot easier to put it in front of you. And if I think I am, so let me do this. All right, so this is where you can download the curriculum from. Christy, are you on the line and able to hear me?
Yep. Excuse me, yes, I'm here.
Okay, yeah, she was actually just taking a nap in the back room, so. I'm going to have her read questions if people had typed questions in, and Dick and I can answer those.
I have somebody here with their hand raised, but I'm looking in the chat in the QA to see if there's anything there. I don't see anything yet, but how many classrooms are currently using this program, or what schools are currently using this program?
Well, that's an interesting question. There's about 40,000 secondary schools in the United States alone, and right now there are, and this is anecdotal data, which is really terrible data, but there's about 400 schools that have downloaded these pieces of curriculum, and it's in about 33 different countries. So. What we've been doing over the last couple of years is figuring out how it works in schools, making improvements and changes to things and putting things in. So if we know where you are, we can find somebody that's, at least in the same state or, deals with the same education hierarchy that you're used to, and they can tell you what they're doing at their school and how it works.
Okay, and then the other one was just all the stuff comes free, like really?
Well, what schools are responsible for is the hardware, and what we did is we teamed up with Studica and said these are the things that we're going to need, so they could put together a package for schools. And now there's a gentleman at Studica. His name is Jim Sheehan. And what Jim does is he gives you a list of these things, and you can go through and check off what you already have and highlight what you need. You can share with him how many people you're planning on training. For example, there was a gentleman I talked to a couple of days ago. And when I first started working with him back in, and I want to say this was 99 or maybe 2000, he had 40 kids in an engineering program. And he was looking for something a little bit more robust, met more standards, and really prepared students better. But what he ended up with, he said he has almost 2,000 students in his program. So we want to make sure that, this whole thing is flexible enough so you can use it, without, too much trouble.
Okay. One more question just came up. How does this integrate if already doing PLTW at our high school? Is it different, a supplement, or unique to Siemens STEM?
Well, the gentleman I was talking with the other day was a PLTW master teacher. And so in the days when I used to train PLTW master teachers, I worked with them. And so I would say out of the 400 schools that are currently using it, there's probably 75 or 80 Project Lead the Way schools. And some of them are incorporating some of these projects in, and then others are, using it as a total shift. So everybody's going to do it differently. There's no right answer to any of this stuff. It's just, what do you think works best with your students and your local industries? Because after all, we're trying to prepare students for the next generation, and we got to make sure that we listen to local industries. We listen to state directors of career and technical education. Let them have a say in what they want to see and how they want to see it. So I don't know. Between Dick and I, we probably have 100 years of educational experience, and it's been different every year. So that's as close as I can come. There's no hard and fast rule on any of this stuff.
Okay, and it looks like that's all the questions we have. I just wanted to let everybody know that I will be sending an email that will include the recording, as well as any important URLs that were noted in the presentation, so you don't have to scribble those down. I'll send you an email that'll have those for you.
Tom, let me jump in. Can you hear me okay?
Yeah, I can hear you, Dick.
Tom, we're looking at two courses here, Siemens Engineering Design, and then the second course, Siemens Manufacturing and Automation. These are basically somewhat sequential. So you would start students with the design course first. Now, if the students already have taken engineering design from another curriculum, they can go into the manufacturing and automation. And that doesn't mean you can't do both at the same time and blend. Because it's project-based, you can move around the various curriculum. Tom, why don't you talk a little bit about that, please?
Well, let me just back up and start by saying that every time I do one of these curriculum design processes, I come away with something new and something exciting. If I can't get excited, then kids aren't going to get excited. So I look for the things that fascinate students, and I try and figure out a way to work around the stuff that they suffer through. And as educators, we know there's a certain amount of suffering that needs to be done in order to arrive at the understandings, but it's not always necessary. Anytime we can throw a challenge to students and put them in charge of the education, they start working harder, and teachers start, there's no rule that says a teacher has to be the hardest working person in any classroom. And, if I want it for a student worse than the student wants it for themselves, I've really bit off a lot of work to get that student where I need them to be. And if the student is so excited that they ask me what I'm doing on Saturday, then I know that I've hit a nerve, and that they're going to do just about anything to bend over backwards to come up with a solution. So what we really need, to do is not to have this be the be all end all and the only thing that you do, but you take a look at it and say, oh, well, I can use this piece of it, I can use all of it, I can use some of it. I know I was down in Memphis with the folks, they wanted to implement this. And, so they have, I think, 17 high schools. Don't quote me on that because I've been wrong in a number of times today already. And they took a look at the engineering design course, and they said, well, really, there's enough stuff here for 2 years. And if our kids did this for 2 years, they'd be really ready. Because they're coming in from a background where maybe the socioeconomics are a little less than you would want. A lot of single income families and that type of thing. So they're spending a little extra time to make sure that the students get all the way through it.
And Tom,
again, no right way. Yeah.
Sorry, I had just another question came in. Do you get into data communications in your curriculum?
There is some data gathering, data processing. You know, one of the colleges that I talked with said that one of the things that anybody coming in to be technicians or engineers and, you know, anything along those lines, they, you know, the more times they can use Excel, the better. So we take a look at, you know, all different kinds of places where we can use Excel as a, you know, analyzing data and, you know, that type of thing. And then, of course, you know, when you're talking about the future of manufacturing, it's all about how these things all interact. So I have a young friend. He was, I think, about 4, you know, when I met him, and you know, we've, you know, talked over the last 25 years, and right now he lives in outside of San Francisco, and he manages a wind farm in New York State from his house in San Francisco. And you know, so the data flows freely back and forth, and we can control things. And like, you know, you can have an entire plant where they have one room where everything is controlled from. You know, I was down in Kentucky, and I went to the assembly plant that Toyota has there. You know, so they make about 7,000 cars a day, and it's an enormous operation. And they have 2 shifts of you know, basically line workers that work on the you know, assembly of cars, and they have 1 shift of maintenance folks who do nothing but go through and play machine doctor and bring all machines back up to snuff so they're ready to go. So I don't know if I even came close to your question, Dick, but
Tom, let me just jump to a different topic. Tom and I are in discussion with Siemens right now for a 3rd course, and the content of which is what we're trying to identify now. But you know, this isn't finished, and you need to be aware that that is going to be happening, and stay connected with us, and we will keep you informed as that progresses.
yeah, we talked to a large number of people who have brought different topics up, even things like middle school. You know, what do we do with our middle school kids? You know, because we've run the gamut from people who need an aid to read to them to, you know, people who might skip high school and go straight to college. So, yeah, there's a lot of great things that we can do, and we're going to look and do our best to get some of these things created for teachers.
Tom, I think we have a school that's using the Siemens Engineering Design with middle school students, but they're progressing slower, and maybe taking a bit longer to do each project, but it seems to be working, isn't it?
Yeah, you know, the comment I hear most from teachers, and I'm going to backtrack just a little bit because there are a few teachers that called me up that in a dead set panic, and it's like it's not working the way I want it to, and you know, we help them sort through that. Primarily, they skipped all the projects and they went straight to all the tutorials, and the kids were, you know, kind of grinding. And once we got them on the projects, then you know, the comments are, this is so much fun. You know, my kids are doing these things. They, you know, they send me pictures, and you know, they really get excited about, you know, the whole process. So you can do this with just about anybody. I know Dick talked me into a project. I want to say it was probably in the early 90s, and he said, you know, we don't have to teach board drawing to young people. We could teach 3-dimensional modeling to 6th graders, couldn't we? And I thought he was just, you know, waxing philosophic at that point. So I said, sure. And the next thing I knew, I had you know, like 600, you know, 6th graders coming to me to learn how to do 3-dimensional modeling. So I was like, okay. So yeah, you can do this with just about anybody, you know, within reason. You know, if you want, you know, people to understand some of the physics, well, they have to be capable, and you know, to understand some of it, you know, as a, you know, child who's like 12 or 13, they don't have the science background or the math background yet, so it takes time to establish that. But it's not a deal breaker. You know, they'll chew into it, and once it makes sense to them, they can, you know, carry that on, and it works for them. Well, if there
another point that I just remembered that's kind of a neat feature is when Siemens provides the design software to you as a school, not only is it available to every teacher in the school, but it's also available to all the students. So they can actually download the software on their home computer. It's a very, very amazing thing that they've done, Siemens.
Yeah, and you know, it's you know, the actual industrial software that you know is used. So Siemens is this giant company, but their clientele, the companies that they serve, you know, basically are in every community. They work from power plants to sewage treatment plants, water treatment plants, you know, you name it. It's all about the software, communication, monitoring, things like that. And so when you take a look at, you know, here's a company with 380,000 employees and, you know, a company list that doesn't end. You know, they're all looking for the next generation of folks that can come to work and do these things. I know when I was just graduating from high school, you could get a job pushing a broom on a construction site, but that doesn't happen anymore, and unless you you know, have some basic skills in further education, you're not gonna make it. Anyway, let me leave one final slide with you in case you want to actually, you know, jot us an email or, you know, call us up on the phone. We're always happy to talk to anybody who can, you know, get a hold of us. The website down at the bottom is where you can download the curriculum. So basically, you know, come in, you tell me who you are, what school you work at, and then you'll get your link to download the curriculum. So does anybody have anything else?
Just a lot of thank yous. So thank you very much.
Well, I want to reiterate that. I thank you all for taking time out of your day to come and, you know, listen to us talk about, you know, kind of what we're passionate about. And, you know, so we look forward to.
Someone's asking about a materials list.
Yeah, is there a material list that are needed to buy to go with the program, PLC motors, starters, etc.? I'd like you to provide, I like that you provide the software. So that's something I can include the link on in the follow-up email so they can visit the website and they can see the list from there. That might be easier.
Yeah, so if you go to siemensdesign.tomwhitestem.com, there's a link on there that takes you to Jim Sheehan at Studica. And Jim would get you that whole list. You know, basically it's a PDF, and you can go and say, "Oh, we got one of these. We got one of these," and then you know what you'd be in for as far as providing, you know, supplies to classrooms. And one thing I will say that we have a school in Michigan that the Education Foundation of the SME basically provided them a grant to get all the equipment that they needed. So there are a lot of industries around in various places that, you know, also are looking to help schools. So at any rate, take a look, and hopefully if you got more questions, make sure you ask.
All right, thank you, everyone.